share with us.
Good morning, folks.
Good morning.
And you can give him a hand too.
Tickled to be here with you, and I think you're going to have some very fascinating, interesting stuff here. Showing how Amber shows that the Genesis flood had to be a global event, not some series of local floods, as some people would like to compromise Scripture. Okay, tell me this, how many of you think that Amber came from tree sap? Raise your hand. 1, 2, 3, 4. Okay, I'm going to show you how that's not the case. That's the common perception among most folks. But so first I'm going to show you what amber is not from. So here you see a cross-section through a tree, and this shows that there are channels that are horizontal, like spoke-like fashion that come out, but also there are channels that go up and down. And the ones that go up and down are called phloem and xylem. And xylem, the group of xylem channels, which are more towards the center of the tree, that's where the water with the dissolved minerals go up and down, mostly up. The phloem is where the sugar that's made in the leaves goes down to the roots, is stored in the fall and the winter, and it comes back up to grow new leaves or new needles in the spring. Those are what constitutes sap. But that has nothing to do with resin, which is what becomes amber. Now, just showing you here that the phloem, I said, is the channel for sugars, and the table sugar that we have in our bowls is sucrose, and it's made up of two simple sugars together. Glucose and fructose combined make sucrose. So those are what are in the phloem. And so when the tree is tapped into the phloem, that's where we get our log cabin maple syrup. Resin, on the other hand, comes from those horizontal channels from the center of the tree, and this is what the tree exudes in response to being wounded. So when something wounds the tree, this is what is done, and it's the same idea as forming a scab when we have a wound in our skin. It's the same idea, to close off that wound. And so you can see here, it flows in those horizontal channels so that the resin can get to the wound site. And it consists of 3 categories of molecules, and these molecules are used to fingerprint where resin came from that becomes amber. So the volatile fraction, that's the fraction of the type of the molecules in the resin that will evaporate out. While they're still in the resin, they allow for the resin to still be in a more liquid form so that it can flow. And so it acts as a plasticizer, making it plastic, making it flowable. And these are just showing you the structures of some of these molecules. And the reason I'm doing this is because these are used to be able to identify where the resin that becomes amber came from, so that they can identify what species a piece of amber actually came from. So each corner or each little stick represents a carbon atom. So for example, this one here has 6 carbon atoms in the ring, 3 more here, and another one there, just to give you an idea of what you're looking at. So you can see there's quite a variety, and some of these get fairly complex. So when they finish evaporating out, then that resin becomes hard. What are you looking at here?
Dash of a car that's seen too much sun.
Exactly. Now this is what happened. The volatile molecules in the plastic evaporated out, it became hard and brittle, and then with minimal trauma, it cracked. So these molecules that evaporate out are the responsible fraction for that new car smell. So that's what you're smelling, is you're smelling the stuff coming out of the plastic. And that's why after a few years, that new car smell goes away, because the stuff has already finished coming out of the plastic. Another category, after the volatile ones that leave, are the constitutive resins. These are the ones that stay there. These are what make up the substance of the resin. And so these molecules I'm going to show you will actually combine and make long chains, polymers, and to make it very strong. And so here you see a variety of these. As I said, they will combine and make, like the way we make a blood clot is the platelets will stick together. Same kind of idea. And so you see here, there's quite a variety of these. And so again, it's the specificity of these molecules that allows us to identify where the resin came from, what particular tree. Then the third category are the molecules and resins that are dependent upon circumstances, such as how much light the plant gets, its genetics, what nutrients are available to the plant, and the type of cells, the type of tissue in the plant that the molecules come from, are made in. So those are the three categories of the molecules that make up the resins. So what do the resins do? Well, we already talked about how they provide convection, they form a scab. And they also deter herbivory, meaning that these molecules make the plant distasteful for insects and other animals that would eat the plant. So they deter the plant eaters. They also provide protection against ultraviolet light. So we're all familiar, especially here in Arizona, at this altitude, of the effect of ultraviolet light from the sun causing skin cancer, right? So it's the same idea. Plants need protection against ultraviolet light as well, and these molecules perform that role as well. And also, especially here in Arizona with our dry climate, anything that can reduce the loss of water from the plant is beneficial. Some of these molecules perform that function as well, saving water for the plant. And then the timing of seed release is critical so that it's released at the right season, so it'll have the proper time to grow when it's supposed to. And then, interestingly, not only do some of these molecules cause the plant to be distasteful to herbivores, they also attract animals that will eat the things that would eat the plant. And pretty clever. Now just think about this. How does that happen by random chance events? It has to be a planned program for these molecules to attract the animals that will eat the insects or other animals that will eat the plants. And then pollinators, so attracting pollinators so that there can be a better yield from pollination. And then there are plant-plant interactions. And this is amazing. It's been known for some time, but we're finding more and more species of plants that do this. So when, for example, a plant is chewed on by an animal, it will release some of these molecules that go through the air, and then the neighboring plants of the same species will then pour out more of the molecules that make it distasteful to the animal that's chewing on the first plant. Isn't that crazy? So it's kind of like sending out a radio signal, except it's a molecular message through the air that tells the other plants, put up your defenses, because someone who wants to chomp you is on the way. And then there's tremendous interaction with the microbes, the bacteria and the fungi in the soil. For example, many plants have a very close association with the fungus that grows in the soil. So intimate that the plant actually provides little entrances for the fungus to grow partway into the plant. And this allows for greater absorption of water and minerals from the soil into the plant, so the plant benefits from the presence of the fungus. So some of these molecules affect these kinds of interactions with that and with other bacteria that will provide things that the plant needs as well. So, as I mentioned, the reason for showing you all these various chemical structures is so that the source of the resin, which becomes amber, can be identified. And so this is analogous to fingerprinting, except it's molecular identifying of the source of the amber, the resin that becomes amber. In particular, this particular species of pine called a kauri pine, and it's different than the ponderosa pine that we're familiar with all around us. First of all, you can see that the trunk is much smoother. Another thing is that it only grows, today, it only grows in one place in the world, and that's part of New Zealand, and that is it. It also has a different shaped cone, much more round than the cones of our pine trees, the various types of pine trees, and it actually has leaves instead of needles. That's rather amazing, the kauri pine. But it's still a conifer, the term used for all pine trees, because it puts out this cone. So as I said, today it only grows in New Zealand, in that particular region on the North Island. But we know from analysis of amber from around the world that this was worldwide before the flood. Everywhere. And the most common source of resin for amber. Now, there are 3 other families of conifers, and here you see ones that are still different than our ponderosa pine. So all of these will put out different types of resins. But also there are 12 families of flowering trees that put out resins as well. And because of that molecular fingerprinting, the sources of the resin in the amber can be identified very specifically for each particular species within those families. So this shows you where the major deposits of amber are located, and as you can see, it's definitely worldwide. So I'm going to show you just a few examples here. So the island of Hispaniola, which is shared by Haiti and the Dominican Republic, has on the north shore, where you see that yellow dot, a pretty impressive amount of amber there. And you see these colors here, the ones that you're more used to seeing when they have insects or parts of plants in them, but also they have these remarkably different colors of amber as well that you're probably not so used to seeing. Rather amazing, green and blue amber. Well, down in the southern part of Mexico there, in Chiapas, there are these multicolored examples of amber that are found down there. Then up in Canada, there's this blood red amber, and its origin is in that first yellow dot that you see there, but they've been able to determine that it was transported to that northeastern location. Now, did that amber climb up on a train and go by tracks to get there? No, something had to move it. And it wasn't airborne, it had to be water. Water had to move that stuff. So you can tell that's not a local flood, it's moving that amber. In Burma, in the northern part of Burma, there are amazing examples, and they're still identifying every year some new kind of find, some new species of insect that had never been seen before, trapped in amber. For example, this one. And also a good part of this frog. And so a CT scan was done, and there you can see clearly the bones. And so what you're seeing is the lower jaw of the frog, along with its spine and the forelimbs. There's a close-up. So that's pretty impressive preservation in this amber here. Well, amazingly, even in some of the stuff coming out of Burma, or now it's Myanmar, are these specimens which actually preserve the original colors in the incense. That's remarkable. So they found 35 different specimens with this amazing preservation here of color. That's astounding when you think about it. So again, there's the worldwide distribution, but now you see the new red dot. This is the latest find because a very powerful tropical storm heaved up from the ocean floor a bunch of amber and deposited on the York Peninsula, the northern part of Australia. And so here you see these specimens that were thrown up onto the beach. And there's a remarkable variety here in color with some of these inclusions. Look at that phenomenal preservation of detail with the wings. And you can even see the eye, that the eye is a compound eye with hundreds of lenses. Tremendous detail here. And then this next one shows that God has a sense of humor. And also, this specimen reminds me of the space shuttles in Star Wars. Look at the shape of that. Isn't that amazing? Yeah. It's a real, formerly living creature. Well, the largest deposit of amber is in the Baltic Sea region. And so you see here where there's yellow, all these deposits on the shorelines, very, very huge, significant ones. And they've been able to determine that they originated in this southern part of Sweden and then were transported to these other shorelines of these various countries here. I've outlined this section that has Russia in parentheses here. When the Soviet Union was intact, the borders of the so-called republics within it really didn't matter a whole lot. They were more for administrative purposes. But this particular section there, with that red line around it, had become populated, I should say repopulated, by ethnic Russians. And so when the Soviet Union dissolved, that remained part of the Russian Federation, even though it's not contiguous. It's like Alaska not being contiguous with the U.S. And I'm going to give you a lot more of that history at the end. There it is. So in close-up, this is that same section, and the capital city here is Kaliningrad. That's its current name. And then on the coast here is this small town called Yantark, which in Russian means amber. So there you see, Yantarkny is the adjective form of the word. And so here I am standing on the coast there looking westward across the Baltic. This is one of the mission trips I was on in Russia. I've been there 14 times. And this is where there's this huge deposit of amber. So this is the area that's mined, and you can see there's a part of it that's much more blue than the rest of it. They call it blue earth. And that's the layer that contains the amber. You can see here how it has a different color than the layers above and below it. And you can see they use very delicate resources here. You know, huge steam shovels. And shovel this stuff out. And then you can see that the machine is put on these supports, because then they'll use a crane, pick it up and move it to another place so they can mine under that. So they move it around from place to place. So this is a major operation. And there you can see some more of the equipment that's used to mine the amber. And this is a room in what's called the Catherine Palace, south of St. Petersburg, known as Leningrad during the communist years. That is, the walls are coated, lined with mosaic of amber. And we're going to get back to this, but first I want to ask you the question, so when and how did amber form? Well, the secular guys tell us that amber formation occurred over a span of some 300 million years, from 15 to 320 million years ago. That's the secular viewpoint. And that it came from, on the evolutionary, again, all this is the evolutionary assumption. The time scale that the first flowering plants only showed up 130 million years ago. But yet, they tell us amber formation occurred over this span. And they found that these came from these conifers, these different kinds of pine trees, especially the kauri pine, which the amber from kauri pine is found worldwide. But here's the problem for the evolutionists. Also resin from flowering trees. So here you'll see amber from flowering trees clear down to here, but yet the first flowering plants weren't supposed to happen until here. Okay, so this is a 200 million year problem for the evolutionists. By their own reckoning, by their own way of dating things. So it's kind of hard to have resin from flowering trees before flowering plants came into existence. You see the problem? Yes? Make noise?
Yes.
Okay, all right. So that's a big oops for the evolutionists. Well, another problem, this one's only a 100 million year problem, is not all that far from here at the Petrified Forest National Monument is this petrified honeycomb, beecomb, found in the later rock. Well, if there's bees, that means there had to be flowers. And yet this is 100 million years before flowering plants were supposed to have come into existence, according to the way the evolutionists date things. See, it's nice, because they trip themselves up for us. All right? And so here we see specimens of bees in amber. And this fellow named Goldtelp is a secular researcher in amber. And he says it's difficult to date amber directly. In other words, you can't just look at a piece of amber or analyze a piece of amber and determine how old it is. What you have to do is find the layer of sediment that it's found in and assume that the date of the amber correlates with the date given to the sediment. All right, so that's how they date it. Well, of course, they date all the sediment in millions and millions of years. So this was published here in Science, one of the top journals. But the secular guys are uncertain and in disagreement about how amber's contents came to be entombed. And you're going to see why here. So here you see some bits of plant material. And you can say, by the way, I should ask you, what's your understanding of how something gets stuck on tree resin?
Touch it.
Like it either crawled up the tree or got blown onto the tree or drifted onto the tree and stuck in the resin? Is that
Lands on it.
the common perception?
Yeah. It lands on it, so.
Lands on it, yeah, from the air, okay,
Well, if we're gonna be, I don't know what that is, but.
all right. So maybe some wind blew some plant stuff and it got stuck on the resin on the tree. And here's a real tiny flower, it's only about yay big. Okay, another flower. Here's an insect. I'm sorry, this flower is about an inch wide. This is a more recent find. Okay, insects could crawl up the tree and get stuck, okay. This one's especially interesting. This flea was examined. They dug it out of the amber. And were able to culture out bacteria on the proboscis, the tip of the flea. Okay, now, here's the deal. That particular bacterium is Yersinia pestis, and I'll bet that means nothing for you guys. Except this is the one that causes the bubonic plague, the Black Death. And that is not so geographically far from us here, because in the Four Corners area, there's still a reservoir of the plague there, in the rats and the rodents. But here's the amazing thing. How are they able to grow this since it's supposedly 20 million years old? You see the problem here. So, problem of the age of the thing and the fact that there's no evolution. It hasn't changed. Here you see with some very fine CT scanning done, the exquisite detail of these inclusions in the amber are able to be determined. Well, here's a larger specimen, and so here's a feather from a bird, and you see there a mite that was on the feather. Scorpions, well, yeah, worms, I guess they could say they climb up the tree, and same with this frog.
Oh my.
Okay, now we're getting some pretty big stuff here. This gets harder to figure out how it got totally wrapped up in the resin. So here's detail on the foot of the lizard, supposedly 100 million years old. How about these termites, which have not evolved? They're the same as today's termites, and they were able to grow out the bacteria in the guts of the termites. I think you probably know that the reason termites can eat wood and digest it is because they don't do the digesting. It's the bacteria inside the gut that breaks down the cellulose that allows the termites to get the nutrients. You know, cellulose is nothing but sugar molecules. Long chains of glucose, that's all it is. So if you have any wood beams or this wood, I assume this is real wood here, furniture here, that's all sugar molecules, by the way, just so you understand. So it's the bacteria that break that stuff down. And so no change, no evolution. Same, even though it's supposedly 20 million years old. How about this mama snail giving birth to baby snails caught in the resin? What's the snail doing up that tree? Okay, here's some beetles. No change from today from the past, 100 million years. Inchworm, no change, 44 million years. Okay, now how about these organisms that live in streams and rivers and ponds? How did they get in that resin? freshwater organisms. What about these critters that live in the ocean? How'd they get on that tree? Barnacles. Okay, isopod. Probably haven't heard that term before, but isopods are very tiny crustaceans and in the same category as shrimp and crab. They're extremely small, and they make up a good portion of what we call krill, organisms that whales will filter feed in massive amounts. Crabs, how'd they get on that tree? Okay, snails from the ocean. Red algae, okay? Red algae grows on the seafloor and it's attached to the rocks on the bottom of the ocean floor. How did that get on that tree? And then here's the killer, trilobite. In amber. Pretty impressive. Okay, ammonite, those are those circular things that are shaped like this, you see over there in the corner, plus all this other stuff in this specimen. So how did all of this stuff get mixed up together in the same piece of amber from the resin on that tree? Whoa. How about hair from mammals? Okay, the cuticle is the outer layer, the outside layer of the hair shaft. And so here you see a diagram showing that anatomy. So that's what your hair looks like. And here's a electron micrograph, a picture taken using an electron microscope, using a beam of electrons instead of light to get the incredible detail. So that's what your hair looks like. Okay, how about a tooth from something that, some kind of egg? How about air bubbles in amber? Well, this particular specimen, evolutionists tried to explain it away by saying, well, that's actually gas formed from the decomposition of stuff in the gut. The gas formed as the bacteria did their work and formed it. But what about these guys? So over 400 specimens of air bubbles in amber were analyzed, and their oxygen content was in the range of 32 to 38% oxygen. 36% here, but 38 also. The air you're breathing right now is 21% oxygen. So this is a much higher level, more than about 60% higher than today's oxygen level. So this is an indicator, it's not proof, but it's an indicator that the pre-flood oxygen levels were much higher. Also, probably the CO2 levels as well, because plants love CO2, they grow. More CO2, more temperature, plants do better. That's why all this garbage today with this climate change, global warming baloney, it's nothing to do with science, it's all about control and money. Okay, this is astounding. So this is an air bubble inside water, inside amber. Okay, an air bubble inside water, inside amber. So when you shift the angle of the piece of amber, the air bubble moves in the water.
So the water's still water in the amber.
That water is still water inside the amber.
Or I should say, look, wow.
Okay, with air inside the water. Air bubble inside water, inside amber. How'd that happen on that tree? So this is analogous to a carpenter's level. That we use how that bubble moves to see whether something's level or vertical. Okay? Okay, has your mind been blown? Alright, so there it is. Hundreds of analyses saying lots and lots of oxygen. Well, the evolutionists interpret it this way, saying that before 60 million years ago, there was a lot more oxygen in the atmosphere. Paleoatmosphere, that's a fancy way of saying ancient air, ancient atmosphere. Well, that's the way they interpret it, but I think appropriately better to use this time frame here so that it correlates with the flood. So gas bubbles are typical amber inclusions. They're not exceptional. They're not rare. Now, I've given this presentation quite a few times, and twice I had to be asked before I finally remembered to look it up. How big is the largest piece of amber ever found? Okay, I want you guys to make a guess in pounds. Someone make a guess.
300.
800 pounds.
800. Not quite. This specimen, these dimensions, 150 pounds. Think of it, one piece of amber, 150 pounds. So that would be the weight of a few of you ladies. Or more than.
But the volume is gonna be huge, cause isn't amber lighter?
It's very, well, here's the dimensions right here.
Yeah.
29 by 22 by 16 inches, so it's pretty, it's dense. It's very dense. This is where it was found, in a coal mine in the northern part of the island of Sumatra in the country of Indonesia, Southeast Asia.
In a coal mine,
Coal mine.
so it migrated underground. Awesome.
Well, actually, several of these pieces are found in coal mines. And this has to do with the mechanism of the flood, which we'll get to.
Absolutely.
So back to the Baltic Sea, because here, that large piece of amber that set the world's record is now sitting in a museum in the Polish city of Gdansk. So Poland has its amber museum there. Russia has its amber museum there at Yautarny, outside of Kaliningrad. Lithuania has its amber museum at Palanga. So they all have tremendous amounts and collections of amber there. So again, that's part of Russia today, and I'm going to get to that history at the end. So here are two secular scientists, a fellow from Berlin and the other one from Florida, who worked together to try and figure out the mechanism of amber formation from resin, and how these organisms could get trapped. So they noted with their work that water delays the solidification, the becoming less liquid of the resin. So they got permission to wound some cypress trees there in Florida. So they got their saw there and wounded the tree. And the resin flowed, went into the water, and they watched it, observed it, and the water kept it in the more liquid form for a much longer period of time. So this lets you know that this is the way by which these things that you saw in the previous slides could get trapped in the resin, because it's in the liquid form. So if it has more time to flow, it can encase things. So it says that water delays this process of solidification. It's normally driven by the oxygen, speeding up the process. So if it's in the water, it's going to flow and stay sticky longer and have a chance to trap stuff, including this feather with insects and a bunch of other stuff. It even caught these insects in the act of mating. So that had to be fairly rapid entrapment. Then they also felt that if this place where the resin had flowed, the water drained and then it became covered with layers of sediment, that the protection provided by the sediment and the pressure and heat provided by the sediment would then cause that amber to form from the resin solidifying. So the question is, can you think of a place here in Arizona that would show you many layers of sediment?
Grand Canyon.
Obviously, Grand Canyon. So there are the layers. Here is the rim, the south rim of the Grand Canyon, 7,000 feet, the Kaibab limestone. And these are all the layers as you go further north into Utah that formerly were on top of the Grand Canyon as well, but were eroded away. Many thousands of feet of stuff overlying the Grand Canyon was washed away. And the guys who analyze this stuff feel pretty strongly that it is now sitting over the southern part of central U.S. and in the Gulf of Mexico. So here, from 1980, Mount St. Helens erupted. A third of a cubic mile of the mountain slid down into Spirit Lake, caused a tidal wave. The lake then washed up the other side of the valley, and when it came back down, it brought the forest with it. And so the forest then is sitting on top of the lake. So these logs have been sitting there getting waterlogged, and they've been rustled against each other by the wind shifting directions, and so bark getting knocked off, trees getting wounded, resin being liberated.
Even dead?
Pardon me?
Even though it's dead? Even though the tree's dead?
Yeah, the mechanism is still intact. Because all that tissue didn't die immediately.
Okay.
So here we're showing this log mat, and bark coming off and forming layers of heat, soft layers of organic material. And as the logs would get totally saturated, waterlogged, the heavier part, the lower part of the trunk, would be the bottom, so they'd be vertical. And so some of these trees would be in vertical positions. And so here you see layers accumulating either from the bark and stuff from trees or from silt coming in, washed in by the river. And so here you see this way of developing these various layers with vertical trees and with this organic material, with the resin being liberated. And so here you see an insect begun to be trapped by the resin, and then the resin overflowing. So here is a picture from a hurricane in Florida. And that's just a tiny little spot compared to the worldwide events of the flood. So this gives you a clue as to how there was massive amounts of resin liberated during the global flood. And that's why we have these deposits worldwide, including this one up in Canada, these more of the blood red type. Now, this again is a secular source. These secular guys did all this work, and we get to put it together correctly. So this is about the Baltic region specifically. So the insects are of modern types, even though they're supposedly tens or hundreds of millions of years old. And their geographical distribution can be determined by where those insects are today, is the way they're thinking. And it says they belong to regions of the earth from all over, not just the ancient Arctic, the ancient northern part, because they're thinking in millions of years, but also all parts of the world. Okay, the whole earth. So what they're saying is what is found in the Baltic came from everywhere else as well. That's what this word allochthonous means. From all over, everywhere. So, water immersion is necessary for amber to have time to flow and encase the organisms, to capture not only the terrestrial but also the freshwater and marine organisms, occur on a worldwide basis. So the simplest explanation is the flood of Genesis. So this is a sequence showing as the waters rose in chapter 7 of Genesis, that it took a few months for the waters to get up. So it wasn't like there was instant covering of everything. It happened in stages. And so that's what this is trying to show, and that it was tremendously violent thing. It wasn't just gentle rain coming down for 40 days. It was a violent process with lots of earthquake activity, lots of tidal waves, lots of hurricanes, all sorts of stuff going on. Now these are things that have been published in the scientific literature which you won't see in the ordinary press. An ocean world, okay, these are all secular evolutionist articles. Evolutionists admit that this planet could be covered almost, I like the way to put almost, entirely by water. We're talking about a time when if you're looking at the Earth from space, you would hardly see any landmass at all. And it would have almost been an ocean world. However, some recent studies suggest that water may have covered Earth's entire surface some 200 million years before the continents emerged. A new theory has emerged that almost all of the Earth has been covered with water millions of years ago. 4 billion years ago, Earth was covered in a watery sludge. 4.4 billion years ago, Earth was flat and almost entirely covered in water with just a few small islands. We see they're inching toward the truth.
Dancing around the edge without jumping in.
Yes, exactly. Now, if they would get rid of the millions of years, they'd be pretty much right there. Land ahoy. Study shows the first continents bobbed to the surface more than 3 billion years ago. So you can see they're all over the place time-wise, but they're emitting lots of water. Well, here's the real story. In the 600th year of Noah's life, in the second month, the 17th day of the month, on that day, all of the fountains of the great deep were broken up, and the windows of heaven were opened. Now notice the specificity to the day. God is telling us when this happened. He thinks that's pretty important for us to know. So here's an artist's rendition of the great fountains of the deep opening up, water under high pressure from the weight of the crust sitting on it, shooting up high. Now the flood was on the earth 40 days, the waters increased and lifted up the ark, and it rose high above the earth. The waters prevailed and greatly increased on the earth, and the ark moved about on the surface of the waters. And the waters prevailed exceedingly on the earth, and all the high hills under the whole heaven were covered. So what part of this means that it wasn't total? It's pretty clear. It's quite clear. So there's one rendition of what the ark may have looked like. We don't know for sure, but it makes sense that it was given a prow so that the waves would keep it perpendicular, so it wouldn't be washed from the side, knocked over. And also this vane back here for the wind to keep it perpendicular to the waves. So the waters prevailed, 15 cubits. Now a cubit is at the minimum 18 inches, maybe even 21 inches. Depends upon which cubit. You know, back in England, the foot used for measuring depended upon who was king and how big the foot was. It varied from king to king. And so the cubit, which is the distance from here, this depression is called the antecubital fossa, because it refers to before the cubit. So the cubit is from the bend in the elbow to the tip of the long finger, middle finger. So, depending upon the person, it would vary. A royal cubit would be longer. So that means this would probably be somewhere between about 22.5 to 25 feet over the highest bit of land. And the mountains were covered, and all flesh died that moved on the earth. Birds and cattle and beasts and every creeping thing that creeps on the earth, and every man. All in whose nostrils was the breath of the spirit of life, all that was on the dry land died. So what part of all and every do people not get when they deny the global nature of the flood? To say it was just a bunch of local floods so that they can say that there was no Genesis flood, because they want to keep that evolutionary time frame of billions of years. Because when you understand that the flood was global, it compresses 500 million years of supposed evolutionary time into 1 year and destroys that time framework that the evolutionists propose. That's the significance of understanding the global nature of the flood. It destroys the evolutionary time scale.
Well, I see that what is their evidence for using billions of years or millions of years? What do they say is their evidence?
Okay, you're using that nasty word evidence.
It's brainstorming.
Well, I mean,
Okay.
what is their presumption of
All right,
what?
everything in evolution is based on assumption, imagination, and circular reasoning. They decide what the outcome is and interpret the evidence to make it look so. That's the answer to your question. Now, we all have the same evidence. Evolutionists, creationists have the same evidence. How we interpret this evidence about the past depends upon our worldview. Did God do it as He said in His Word, or not? It always boils down to that. So they interpret the same evidence we have using their assumptions, their imagination, and circular reasoning. All right?
Okay.
So these are the things that show you how violent the flood was. This is an underwater volcano photographed in recent times. Okay, instead of saying landslide, marine slide, meaning landslides under the ocean, hundreds of miles wide. Tsunamis, humongously Genesis. So he destroyed all living things which were on the face of the ground, both man and cattle, creeping thing, and bird of the air. They were destroyed from the earth. Only Noah and those who were on with him on the ark remained alive. So again, the totality of the flood. So that's the story here. So I just want to make the point that the ark is a picture of Christ. They were saved in the ark. He is our ark for salvation. I see time has run out.
Unfortunately.
Okay, so I'll stop with that, unless you want to see some slides about the history. 15 slides?
15 seconds? Yeah.
Yeah.
Okay, we'll make it fast. So this was Europe in 1700. Sweden controlled most of the Baltic coast. Russia did not have Baltic coast. Peter the Great wanted to have his window on the west, his seaport. Frederick I of Prussia also wanted control more of the Baltic because Prussia was just this and this, and he wanted more control here. So he said to Peter, let's have a war against Sweden and get some of this coastline. Peter said, great, let's do it. So they did. So then Russia acquired that land then to the seacoast. So as a thanks, Frederick gave Peter this room of amber, a room coated with amber. It was put into this modest little palace here, the Winter Palace in St. Petersburg. The city was founded in 1703 on marshland. They dug canals, drained the land, built the city. However, the granddaughter of Peter the Great, Catherine, who's now the Tsarina, said, well, down here I want my own little modest palace. And so that's part of it. That gives you an idea of how big it is. And she moved the amber room to this palace. So there it is. So this was the amber originally given by Frederick I. So this was the location until World War II. As the Russians saw the Germans coming, they tried to take the amber off the walls, but they didn't have enough time to do it properly. So they wallpapered it, hoping to fake out the Germans. Didn't work. The Germans came, they had time, so then they removed all the amber, put it in 30 wooden crates, and then destroyed the building. That's the amber room. Okay, so this was part of Prussia. This was German-speaking folks. So as in World War II, as the tide of the war turned and the armies are heading west, the Russian army is heading west, Soviet army, these German-speaking peoples realized they needed to get out of Dodge or be killed. So they evacuated or were killed. So Russia government, Stalin, the communists, repopulated this only with ethnic Russians. They renamed what was called Königsberg, which means King's Mountain, to Kaliningrad, one of the Soviet leaders. So the Russians, there it is, the original Königsberg, returned the favor of the destruction of the Catherine Palace. So this was where the amber was stored, in Königsberg. And that's what the Russians did to it. Okay. So the question is, what happened to the amber that was there? Nobody knows. It wasn't in the ruins. Some people think it was loaded on ships and then the ships sank in the Baltic. Nobody knows. But it's been reconstructed. The Russians had the blueprints and they had photographs, and so they faithfully reconstructed the room. So that's what is seen today. All right.